All right, so I've shared the screen. Just let me know once you're able to see the screen. Are you able to see the screen?
Yes, ma'am.
Okay. Right. So we are going to discuss some special sequences, right? Okay. So initially, we have been talking about numbers, about natural numbers, right? Like 1, 2, 3, 4, and so on. All the positive whole numbers are included in the set of natural numbers. So we have been discussing some sets like of natural numbers, of positive integers, negative integers, and stuff like that. Okay. Now, and after that, we talked about some sequences as well, but we did not discuss them in depth, and we will not be doing that because we have a separate chapter for that. In this chapter, we'll only talk about these sequences: square numbers, cube numbers, and triangular numbers, right? Only these sequences. Okay. So when we talk about the sequence of squared numbers, what do? We square our natural numbers: 1 square, 2 square, 3 square, 4 square, 5 square, and whatever we get as a result. 1 square is 1, 2 square is 4, 3 square is 9. This new set or sequence is basically the sequence or set of square numbers, right? Is this thing clear?
Yes, ma'am.
Yes,
Okay.
ma'am.
And then when we talk about cube numbers, simply we have to cube the natural numbers. Okay, so we have 1 cube is 1, 2 cube is 8. Then we have 3, we have to cube 3, 3 cube is 27, and so on. So this set of 1, 8, 27, 64, and 25 is going to be cube numbers. It's going to be the set of cube numbers. You can call it a sequence or a set, that is completely fine. In this chapter, since we have been discussing sets, so it's okay if we call it a set, okay? Right. And then we have triangular numbers. Now, square numbers was easy, cube numbers was easy, triangular numbers, we have to discuss that. Okay. Now, in this set, think of all these as triangles, okay? And every time we have to make a bigger triangle. So this triangle has one level only. So since one dot is used, we have one. In this triangle, we have two levels. So we need 1, 2, and 3. So next number is 3. Then in the third triangle, we have three levels: 1, 2, and 3. And we need 1, 2, 3, 4, 5, 6 dots. So 6 is the number, right? So this set of 1, 3, 6, 10, 15 is called the set of triangular numbers. Why? Because we have these numbers because of these triangles. Every time we're trying to make a triangle with an extra row, right? So we had 4 rows in this, and in this one we have 1, 2, 3, 4, right? We had 1, 2, 3 in this one, and in this one we have 1, 2, 3, 4 rows. So is this concept clear?
Yes.
Yes.
Sure, Amir?
Yes, ma'am.
Okay. All right. So let's talk about the questions now. We have to discuss some questions as well. Okay. So these are 3 questions which we will discuss. Okay. Write down, this is the first question. Write down the next 2 prime numbers after 53. Okay. So let's start our counting after 53. After 53, we have 54. 54. It's very obvious that we have an even number here, so it is divisible by 2. 54 cannot be the choice. When we think of 53, what do you, 55, okay, and what about 55? Yes, it would be divisible by 5, so it cannot be a prime number. 56, again, it has even number over here, so it cannot be divided. It would be divided by 2. Then we have 57. What about 57? Any idea? Is it a prime number? It looks like a prime number, but is it a prime number? Because it is not divisible by 2. It's not divisible by 5. So, yes, guys?
Ma'am, it is divisible by 3.
Very good. So, it is not a prime number, right, Sunny?
Yes, it's divisible by 3.
Yeah. Then we have 58. 58. It is an even number. It is divisible by 2. And then we have 59. Okay. Now, this 59 is basically our next prime number, right, guys?
Yes.
Okay, so 59 is the first prime number. Then we have 60. Again, we have 0. 0 would be divisible by 2. So we have 61. And then 61 is not divisible by 2. 6 plus 1 is 7. It is not divisible by 3. It is not divisible by 4. Right? So it is not divisible by any number other than 61 and 1. So 59 and 61 are the two next prime numbers after 53. Is this example clear?
Yes, it's clear.
Okay. Then we
Yes.
have a second question. For the set of numbers 2, minus 2.3, under root 5, pi, whatever, write down which are integers. Okay. Now I want Amir to respond for this question. We have these numbers 2, minus 2.3, under root 5, pi, 5, 0.333. Which of these numbers is an integer? You can think and let me.
Ma'am, 2 is an integer. Ma'am, 2 is an integer.
Yes, very good. And what about some other
2,
integer like?
5,
Yes, 2 and 5.
2, 5.
Very good. And yes, do we have some more integers?
Yes, ma'am.
Where?
Square root 5.
Under root 5? This number?
Yes, ma'am, under root 5.
No. In integers, we only have whole numbers, right? When you will solve this
Have.
under root 5, you will see that it is a decimal number. It is not a whole number. So under root 5 is not an integer. Okay? Is
बस
this
यही तो है मैम क्योंकि वो तो
हाँ जी,
पॉजिटिव होल नंबर्स
बिल्कुल. Positive integers may we have negative numbers as well, but only whole numbers, right? This is the set of integers. We are going to have all the negative whole numbers like -3, -2, -1. We have 0, and we have all the positive whole numbers like 1, 2, and so on, right? So in the set of integers, we have both negative and positive numbers. Yes, if we talk about positive integers only, then we'll have positive numbers. If we talk about negative integers, we'll have negative only, okay? But for integers, the only condition is it should be a whole number. So Saneem and Amir, is this clear?
Yes, it's clear.
Okay. Now Saneem, I want
Yes.
you to tell me the set of rational numbers.
2 is a rational number, minus 2.3 is a rational number, 5 and 0.333.
Okay, so you are saying 2 is a rational number, minus 2.3, then 5, right? And
Yes. And
okay,
the-
excellent. Very well done for these three. You were 100% correct. But look, 0.333, we have these three dots after 0.333, which means that it is non-terminating decimal, right? So yesterday we discussed in the definitions of rational and irrational numbers that in rational numbers we have terminating and recurring. Do you remember?
yes, but we can write 0.33 as a fraction.
As recurring number, right?
Yes, it is a recurring number, but we had a process, I guess, by which we can write it as a fraction. So anything
Yes,
that can be
1 by
converted.
3. Yes, 1 by 3. Okay, very good. Excellent. Yes, you're very right. Okay. So the thing is that obviously 0.333, we have been doing, such calculations where we have 1 by 3. So we are used to such numbers, right? For this number, yes, you are right. This would be a rational number, but why? Like, this is my question. What made you say this is a rational number? Because it is a recurring a number, that's why?
Because I had it in my mind that like there's a process by which you can
Yes.
just convert
Okay.
a
Okay,
recurring number
very good.
into.
Excellent. But what if you had a number like this one? 0.121212. Like what about this number? It's going on continuously. So is it a rational number or irrational number?
Well, this can also be converted into fraction.
Okay. So you're trying to say that whatever recurring number you have, since you can write it as a fraction, so through that logic, you are saying that it would be a rational number, right?
Yes.
Excellent. Very well done. Okay, this is correct. This is 100% correct. Okay. Okay. And Amir, can you help me with the last one, with the prime numbers?
Yes, ma'am. 5.
And
Just we have 5.
no, we have 2
3,
as well.
like 8.
We have 2 as well, right? So 2 and 5 both are prime numbers.
Yeah.
Okay. Is this clear?
Yes.
Okay. Then we have the last question. Then we'll talk about the next chapter. What is the sum of second square number and the third triangular number? We have just discussed square numbers. We have discussed triangular numbers, right? I'll give you a quick recap. Here we have a table in which we have both squared numbers and triangular numbers. So second square number. First square number is 1, second square number is 4, third square
Second
number
is
is
4.
9. Very good. Second is 4. And what is the third triangular number? Yes, Sunny?
6.
6.
Very good. Okay. So we have 4 and 6, and they want us to find the sum. So this is 4 and this is 6. So this would be 10.
And
So are we clear with all these questions?
Yes.
Amir, are you
Yes.
clear with this one as well?
Yes, ma'am.
Okay. So every integer is also a rational number. This is why 2 and 5 are rational numbers as well. This is very obvious. We have terminating decimal. This is why it is a rational number. And for 0.333, since it is recurring, and okay, you can also think of it that you can write it as a fraction because it is recurring. So we know it that way as well. So this is also a rational number, right? We have discussed all this yesterday. So I assume that everything is clear from this chapter. Then we can start new chapter now, okay? Hello,
yes, it's clear.
Turhan. How are you?
I'm fine, Alhamdulillah.
Okay. All right. So let's get started. We have to discuss the second chapter. All right. Okay. So it is chapter number 2. Set language and notation. Okay. So do you guys know what sets are? Any basic idea, any definition which comes to your mind when we talk about sets? Any random guess? Anything?
It is when specific terms are grouped into specific groups based on what
Very good.
they define or what they.
Yes. Yes, yes, yes. Very good. Okay. Anyone else? Okay. Let's define a set together. Okay. So we are going to define sets. Okay. So a set is a collection of well-defined, as the name said, well-defined and distinct objects. Distinct means different, right? Now, these two terms are very important. Okay. A set is a collection of well-defined and distinct objects. For example, we have been discussing the set of even numbers, right? When we talk about the set of even numbers, how do we write it? 0, 2, 4, 6. Okay, so it is well defined. We have defined that this set is going to have even numbers only, and distinct means कि कोई भी number इधर repeat नहीं हो रहा. Every number is different, right? So is this clear?
Yes.
Okay. Other than this, we know that we have set of natural numbers, which we discussed in last class. 1, 2, 3, 4, and so on. So we have all the positive whole numbers, okay? So these are some basic examples which you guys must be familiar with. But since now we're talking about sets, so we have to discuss some extensive examples too. Okay, let me define a proper set. Now this is a set. It's A. And how do we write it? A has X such that X is a natural number. Now this A is basically equal to N, the set of natural numbers, right? But we can write it this way as well. And how do we understand these wordings? The set A has X only, and what is X? X is a natural number. This means that A has all the natural numbers, okay? So since this is the set of natural numbers, we can say that both these are equal, right? Okay, let's talk about another example. We have B. B has X such that X is greater than equal to 2 and less than equal to 10. So what elements are we going to have in this set? Anyone?
From 2 to 10, and 2 and 10 are included.
Yes, very good. Why? Because we have less than equal to and greater than equal to. So Amir, can you tell me the elements? Exactly what elements we are going to have?
2, 4, 6, 8, 10. No, 2, 4, 2, 3, 4, 5,
Very
6,
good.
7, 8, 9, 10.
Excellent. Okay. Till 10. Okay, excellent. So we know this as well. Okay. And then let me define the last set. We are discussing examples. So here we are going to have X. X is a prime number less than 13. So in this set, we are going to have all the prime numbers which are less than 13. So 2 is a prime number, it is less than 13. 3 is a prime number, less than 13. 5, and yes, anyone
5,
else?
7,
Very good.
5,
11.
7,
11. Okay, 9. No,
9.
not 9. Not 9. 9 is divisible by 3, right? Right, Amir? 9 is divisible by 3. So it
Yes.
cannot be a prime number. A prime number is a number which has two factors only, 1 and number itself. So is everything clear, Turhan, Amir, and Sunny? Any questions so far?
No questions.
No, ma'am.
Okay. So we talk about intersection and union, and then we'll directly go to Venn diagrams, okay? The exam related content. Okay. All right. Let's talk about intersection of sets. Okay. Now, obviously, we are in O levels, we are not doing metric, we're not doing FSC, so we are not interested in definitions for learning purpose, right? Obviously, we need definitions just for understanding, but they don't ask you definitions and all that content in CIEs and Cambridge exams, okay? So we define intersection of sets in an informal way. We have common objects slash elements, whatever you call. You can say if you have objects in sets, you can say you have elements in sets. It's totally on you. We write down common elements of sets. Okay. Intersection is denoted by this symbol, right? Okay. So in intersection, we have common elements only if A is the set of even numbers starting from 2, 2, 4, 6, and ending at 8. And if B has x such that x is a prime number less than 13. So what is A intersection B? Okay. Now the very first thing is we should be clear about this set and this set. Okay. We know what A has, but for B, everything is written in English. Let's just write down the elements which we will have in B. Who's going to help me with this? We have prime numbers less than 13, 2, 3.
3,
2, 3, 5,
Yes. Okay.
5, 7, 11.
5, 7,
11.
11. Right. Okay. Now we're interested in intersection. A intersection B, we need to write down the common elements. Okay. So what is coming common?
2.
Very
2.
good. Okay. So we know what intersection is, right? Okay. And now if I talk about union, union of sets, we say set of all elements in the given sets. Okay. So for union, obviously you will have 2 sets or 3 sets. That totally depends. It could be 4 as well, denoted by U. Okay. So let's say we have set A, which has 1, 2, and 3. And in B, we have all the odd numbers till 5, okay, and you have been asked to write down A union B. So what is the definition saying? Set of all elements in the given sets. Given set is A and B. So what are going to be the elements? Who's going to tell me?
1, 2, 3, 1,
1,
3,
2, 3, 5.
Okay, yes, again, 1, 2, 3, and
5.
3.
Like
wait, Saneem, what are you saying? 1, 2, 3, and
Would we repeat the numbers or not?
exactly no. Very
Then
good
it's gonna be 5.
question. Okay. Yes. Why? Why can't we repeat numbers? Because when we define sets, we said a set is a collection of well-defined and distinct objects. The word distinct means we can only write different and distinct elements. Okay. If we write down 3 two times, this would not be a set, right, guys?
Yes.
Okay. So we are
yes,
clear with union 100% and intersection.
yes, ma'am.
Yes.
Okay. All right. So let's talk about the main thing, which is very, very important from exam point of view. That is Venn diagram. Are you guys familiar with Venn diagram? Do you know what a Venn diagram is? Any rough idea? No?
Basically a box which has 2 or 3
Yes.
circles.
Very good. Very good. Okay. Okay. Excellent. Okay. So Amir, do you have any idea?
Yes, ma'am. Like we have to shade the part of
Yes.
the
Yes.
box. Venn
Very
diagram,
good.
we have to shade the part. Like the question is like A intersection B or
बिल्कुल, बिल्कुल, बिल्कुल.
intersection or universe.
Excellent. Okay. अच्छा ठीक है. You guys know. Okay. So this basically, this green box is the universal set. Universal set. Okay. And universal set के अंदर हमारे पास जितने भी sets question में given होते हैं, they all are included in universal set. Okay. It could be in questions कि आपके पास universal set ना हो. It could be कि वो हो. ठीक है. मतलब ऐसे भी हो सकता है कि आपके पास सिर्फ ये 2 sets हो जिनको हम A and B कह रहे हैं. ठीक है. लेकिन it could be कि आपके पास universal set B हो. ठीक है. But universal set होगा just so everything is included in the universal set. Right. So, okay, let's just discuss a few terms and then we'll talk about questions. Okay, so this basically is the universal set. Then if we write P with this sign A, it means P belongs to A. Okay, this sign basically is belongs. Just know that. I'll rub this. Just know the sign means belongs. Okay, is it clear, Turhan? Okay, then we have A intersection B. So we know that the sign means intersection. Then we have A union B. So we know that the sign means union. And finally, we have A complement. Okay, this means complement. And what it basically means, everything in the universal set except A. Right, guys? Are you familiar with complements?
Yes.
Okay.
Yes,
So A
ma'am.
complement means everything in the universal set except A. Let's say I have been asked to shade A complement, so I will shade everything except A. Yes? ऐसा ही
Yes.
होगा?
Yes, ma'am.
Okay, very good. So you guys know basic ideas and all that. Okay, all right. So let's talk about some questions which are important from the exam point of view. I'll clear everything and let's start off with the questions. Okay. So this is the very first example which we are going to talk about. We have two sets. This is A and this is B. And this obviously is the universal set. This is A and B. And what if I say what is A intersection B? Now this is the basic, most basic example. What are we going to have in A intersection B?
The middle part.
This region?
Yes.
Okay. All right.
Yes.
Yeah.
And this is the first example. What if I say Amir, is it clear?
Yes, ma'am.
Okay. Now we have, again, this is the universal set. This is A, this is B. And the question is A intersection, sorry, A complement intersection B. Now, how are you guys going to carry this question? Like, what would be your answer?
If A intersection B would be the middle
No,
part,
A
and we the
complement
middle part
intersection.
and except
A complement intersection B. Anyone? Okay. Now, this example was very easy, okay? But when we discuss such examples, things get complicated. So I'm going to share a method which would make every question the world's easiest question for you. Okay, and what is the method? I'll tell you. And this is a very famous method. I've seen many teachers using this method. So let's number our sets. Let's number these spaces we have in the universal set. Let's say this is 1, this is 2, this is 3, and this is 4. Okay, I have numbered every space. All right, now let's talk about A. What do we have in set A? Yes, Amir, what do we have in set A? Which number do we have in set A?
2,
2 and
2 and
yes,
3.
very good, excellent. Okay, so what am I going to have in A complement? A complement is
4
everything
and 1.
in the
1
universal
and
set
4.
except A. Very well done. 1 and 4. Okay. And Turhan, what do we have in B?
We have 4 and 3.
Excellent. We have 4 and 3. Right. And now if I ask you, what is A complement intersection B? So can you use these sets directly? What would be your answer?
One, four, three. 1, 4, 3.
No. We're talking about intersection. We're talking about the common number in both these. Okay. A complement B intersection. Intersection means common numbers. We're not talking about union. Okay. Be very clear with this. This side is for intersection. So what is common in this set and this set?
4.
4. Right, Amir?
4.
Okay. And where is 4?
Yes, ma'am.
Where is 4 in the set? Here is 4. So this would be the answer. So using this method, you guys would be able to solve every question and the answer would be certainly correct. There's no point in thinking that what would be A complement first to state A complement, then you take its intersection with B. No. Use this method every time, okay? We'll practice more questions so you will get a better understanding. Let's talk about the third example now. Is it clear, Turhan? Turhan, is it clear?
Yes.
Okay. So we have a universal set with A and B again. And this time around, my question is, what is A union B whole complement? Okay. Again, we are going to do things in same way. We will be following one method for every question, right? So let's do it. Okay, so the very first step is to name every region. Now this is 1, this is 2, this is 3, and this is 4. First, let's find A union B. Saneem, what is A union B?
2, 3, 4.
Very good. So what is A union B whole complement, Amir? Now first think about it. You have to think, what do you have in the universal set? You have 1, 2, 3, 4. Yes, Amir, what do you have in the universal set? 1, 2,
Yes, ma'am.
3, 4.
1,
Now
2,
in A union B whole complement,
1.
very good, 1. Okay.
So
And
it
yes. So
first question, ma'am, ये क्या है?
acha, so we have to shade this region. Okay, you don't have to think about the question किसी और तरीके से, just do it this way, right? So are these 3 examples clear?
Yes, ma'am.
Okay, so I'll clear this and we'll talk about the 4th example, and you guys have to tell me the answer, okay, using the same method. I want to see if you are understanding everything or not. Okay, so obviously I'll help you, but just so we all are clear with everything. Okay, again universal set, एंड अभी तो हम 2 की बात करें ना, नेक्स्ट एग्जांपल में हमारे पास 3 सेट्स होंगे. ओके, नाउ दिस इज द यूनिवर्सल सेट, दिस इज A and this set is B. Okay, and my question is A intersection B complement. Yes, so just do it. I'll give you 2 minutes and just tell me the answer, okay, the shaded part. I want you to name the region by yourself and do everything. Even if you get the wrong answer, I would not mind that. You guys know that, okay? It's just so I see if you're able to understand everything or not. So you have 2 minutes. Just do it and let me know.
Ma'am, universal set?
Okay, so you are saying that this would be universal set पूरा?
Yes, ma'am.
क्या मतलब इस बात का कि you're saying कि ये सब हमारे पास आएगा इसमें?
No, except A intersection B.
Except A intersection B, मतलब हमारे पास ये सब आएगा, ये कह रहे हो आप?
Yes, ma'am.
अच्छा, okay, I'll tell you the answer is wrong. Okay, now
Yes,
yes,
we'll shade the A region. A खाली shade करेंगे और वो intersection वाला नहीं करेंगे.
this,
Yes, और
okay,
intersection नहीं, हाँ.
ठीक है. And what about you, Turhan?
It will be this and the universal set.
Okay, this as well, right?
Yes, ma'am.
Okay, so I'll tell you. Saneem is correct. Very good, excellent and very good. जिन्होंने try किया, excellent. Okay, Saneem is right. यही region होगा जो Saneem ने बताया. But let's see why. Okay, I think Amir का answer and Turhan का answer थोड़ा सा mismatch इसलिए हुआ है because you guys need to see this कि complement सिर्फ B के ऊपर है. Amir, we only have A intersection B complement. It is not A intersection whole complement. ठीक है? अगर तो A intersection whole complement होता तो फिर very good, आपका आंसर बिल्कुल ठीक था. लेकिन we have A intersection B complement. So let's do it the way I'm telling you guys. Again, 1, 2, 3, 4. Okay, do every question using this method and answer would be correct 100%. Okay, so are you clear with this कि हमने naming कैसे करनी है, numbering कैसे करनी है? You can use ABC as well, that's your choice. But is this thing clear?
Yes.
Yes.
Okay, let's write down A because we have A first. So A के अंदर क्या क्या है? In A we have 2, we have 3. Okay, then what do we have in B? We'll talk about B complement later on. What do we have in B? We have 3 and we have 4. Okay, so we are clear with this as well. Okay, finally we need to write down B complement. So what are we going to have in B complement? Given that universal set mein you have 1, 2, 3, 4. Yes, Amir, what do we have in B complement?
1, 2.
No, No. We have 3 and 4 in
Four.
B. We have 3 and 4 in B. In B complement, we have every element of the universal set except those in B. Yes. B may we have 3 and 4. We'll cut it and we are left with 1 and 2 only. So in B complement, we will have 1 and 2
तो
only. Right?
यस मैम मैंने यही बोला था.
नहीं एक अच्छा आपने 1 and 2 ही बोला था इन बी
जी.
कॉम्प्लीमेंट ये बोला था आपने
यस.
अच्छा आई एम सॉरी अच्छा ठीक है फिर ए इंटरसेक्शन बी कॉम्प्लीमेंट में वी आर गोइंग टू हैव व्हाट टर्म है
ए 2.
very well done excellent okay and now if we look at the diagram ये 1 है ये 2 है तो ये सारा शेड होगा जो सनीम ने कहा था ठीक है only 2 right so do every question this way and your answer would be 100% correct right is it clear to Han yes Turhan are you clear with this okay I can't hear you right so any questions so far
Yes.
okay all right okay so any questions Amir Saneem Turhan we have 2 minutes
नो मैम एक और क्वेश्चन इसका प्रैक्टिस करवा देती
हाँ
ताकि
obviously
थोड़ा ज्यादा
we
क्लियर.
will practice more questions in tomorrow's class obviously because we have to talk about 3 sets and all that okay don't worry about that okay let's do
Okay, ma'am.
another question in 2-1 okay okay let me just stop this okay so we have A B this is A and this is B and the question this time is A complement intersection B okay so I want let's do it together then because we have less time so right step 1 name the regions 1 2 3 and 4 right okay now step 1 is to write down A what is A who's going to tell me A what are the elements of set A
2 and 3.
very good okay what are we going to have in A complement then
4 and 1.
yes Amir did you understand this
Yes, ma'am.
why do we have 1 and 4 in A complement because in the universal set we have 1 2 3 4 ठीक है and when we talk about A complement has मेरी wordings को गौर से सुनना every element of the universal set except the elements of A में 2 और 3 थे ना तो मैंने 2 और 3 को कट कर दिया so we are left with 1 and 4 only ठीक है तो A complement में we have 1 and 4 and if I talk about the set B में we have 3 and 4 तो A intersection A complement intersection B में we will have what who's going to tell me this is A complement this is B
4.
yes A complement intersection B में we will have 4 okay तो shaded region कौन सा होगा this 4 only
4.
right is it clear now
Yes, ma'am.
okay obviously we will discuss more examples in next class so don't worry about that but is everything clear